All right, let's take a look at IPv4 addresses. This is not meant to be an in-depth look into IPv4 addresses. There's a lot of components that go into IPv4 addresses, and that's a whole nother class. But what I want to do is make sure we have a basic understanding and overview of IPv4's addresses, what they look like, how they're set up. So what we're going to be talking about is IP addresses, what they look like, how they are formed, and then we're going to take a look at the network side of it, the host side of it, the subnet masks. We'll talk about some different address types when it comes to IPv4 addresses, and then some unique networks and addresses that are represented by these IPv4 addresses. Now, from what a computer sees, it just sees ones and zeros. So an IP address, really, when you boil it down to, is just 32 bits, 32 ones and zeros. 10 to the 32nd power gives us more than 4.2 billion addresses. So this is what an IP address looks from a computer standpoint. Of course, we don't really like to read things from a computer standpoint, so the first thing we do is break this into bytes or octets. So there is 4 octets, and this is divided up using a dot in between them, or a period in between each one of those. So we've got 8 bits, a dot, 8 bits, a dot, 8 bits, a dot, and 8 bits again. We don't really read binary, and so instead we represent them by decimal numbers rather than the binary numbers. So when this gets translated into 192.168.0.32. So there you have it. There is an IP address and why it's formed the way it is. Just to look at the ranges of IP addresses, if we had all zeros in the bits, this would be representing a decimal 0. If we had all 1 in the bits, then this would be representing a 255. So our range in IP addresses are 0.0.0.0 to 255.255.255.255. Now with the classful system, we've got the first side of this, which defines the network side of this, and then we've got the second side of this, which defines the host side of this. This is a class B address, which is why this is a class C address, which is why I defined the first 3 octets as being the network side of this, and the last octet as being the host side of this. So within here, this network right here would be represented by 192.168.0, and the network address is the first host within there, or the first IP address within that range, which is .0. So this network right here is represented by 192.168.0.0, and one of these hosts on here would be one of the host addresses. So let's say this computer right here is .32, perhaps this laptop right here is .55, and so on and so forth. And so those host addresses get assigned into the network. Subnet masks define which of our bits are going to represent the network and which of the bits are going to define the host side. The network side are defined with the subnet mask as being, or the bits and within the subnet mask as being 1. So if this example right here, if this is the network bits, then these would all be assigned in the mask 1s for each one of those bits until we get to the end here, in which case we'd have 0s because they're not network bits, or when they're not network bits, that's the host side right there. So what this has defined is a subnet mask defines which bits are the network side of it and which ones are the host side of the address. Now, similar to an IP address, the range from these subnet masks is anywhere from all 0s to all 1s, and therefore defining the range of the subnet mask being 0 to 255. But what's interesting about this is really what we do is we define the network bits from the left all the way to how many bits we want to claim for the network side. So it ends up being that this range jumps a little interestingly, and if you don't know the mechanics behind of how these subnet masks are created, then it could be a little confusing. If we have all zeros, then that's a 0. But if we turn the first bit into a network address, at that point in time, then we have 128, because this binary or this binary number, when it's translated into decimal form, would be 128. Let's say we borrow another bit, and so now we get 192. Let's say we borrow another bit, and now we've got 224. If we borrow another bit, we've got 240. The next bit would be a 248. The next one would be a 252. The next one would be a 254. And then finally 255. And so what ends up happening is that we go from the 0, 128, 192, and that's what we see within our subnet masks when we create the subnet masks, was one of the numbers of these 9 different numbers. And so that would be the subnet mask range, and all it's doing is it's representing those binary bits that are on the back end, and those binary bits define what bits within the IP address range are actually the network side of it and what is the host side of that address. So with our address types, we've got a 192.168.0.0. This, in this range right here, would represent the network. If we're not doing any subnetting, that first address within the range represents the network address and shouldn't be used for one of your hosts. The last in a range, so if once again, if we're not subnetting and this is just strictly a class C address, the last in the range is the broadcast address. And then, and that's what's used for broadcast in that network. Everything in between now are what we can assign to specific machines. So these are the host addresses that we can assign to those machines. This one right here, the 192.168.0.1, is considered the first usable address, and the 192.168.0.254 is considered the last usable address. And so then all of the addresses assigned to the machines will just count up in between there. So 1, 2, 3, 4, 5, those are all assignable to machines within this network, this 192.168.0.0 network. Now, we already said that a 192.168.0.255, if we're dealing with a classful address here and we have not done any subnetting, that represents the broadcast address. And so if a packet is destined for this network right here as a broadcast address, it can come into this network, and then what will happen is this will get broadcasted out to the devices on that network. So that's the broadcast address for that network, and this would then be considered a broadcast domain, because that's where this packet right here going destined for this address would get broadcasted out into this network. Hope this video is helping you out. Can you help me out by hitting that like button?